Yeah, so welcome to the next class, dear students. So in the previous class, we have discussed the introduction about the tree. So what is tree? And then the basic terminologies about the tree. So in the terminologies, the main things are what is the root node and what is the edge, and then what is depth of the tree, height of the tree, and the degree of the tree and path of the tree. So these five are very very important. So other things are very well leaf node, sibling concept, internal node, terminal nodes. So these are all the normal things you should know already. Okay, so the main five are very very important. How to find the height of the tree, and the depth of the tree, degree of the tree, and how to find the path of the tree. So this is very very important. So that we have discussed in the previous video. So now, also previous class. So now we have discussed about the binary tree. So we have two classification of the tree. One is general tree, other one is binary tree. So what is the difference between these two means? In general tree, each node, each root node contains many children. So that is called as the general tree. In binary tree means, okay, before we will go to the binary tree, I think you all know the meaning about what is binary. So binary means two. So here every node contains at most two children. So that is called as a binary tree. Okay, so either the tree contains every node contains zero children, one children, and two children at most. This is called as binary tree. So that is the difference between general tree and binary tree. So if the general tree means the every node has many children, that is general tree. Binary tree means every node has exactly two children or at most two children. That is called as a binary tree. Okay, so these are the examples of binary tree, and this is the a okay exactly every node has a two, not more than the two. It's a two exactly. So here also exactly the two children. So these are all called as the binary tree. A binary tree is a data structure specified as a set of so-called node elements. The topmost element in a binary tree is called as a root node, and each node has either the zero children, one children, or at most two children. This is about binary tree. So next, similar. Okay, here the similar binary tree. So here the name, the tree is named as the label of character. Here the nodes are labeled as the alphabet numbers, but the structure is same structure. So this is a tree with the same structure as well as this is called as a binary tree. Okay, and this is the copies of binary tree. Both are labeled as the numbers. So this is a same structure with the same copy. And here, one more terminology is important: complete binary tree and full binary tree. You all know binary tree means every node contains at most two children or called as binary tree. Here, the complete tree, complete binary tree means we have to fill the nodes from left to right. Here, the first, okay, you have to take a root node A, and then you have to fill the left of A first. So that is a left to right. We have to fill the tree from left to right completely except the bottom level. This is a okay bottom level. So now in this example, so here the levels of the tree is zero level, first level, second level, and third level. Third level is the last level. So here only exception at the bottom level, and remaining level should be completely filled from left to right. So that is called as a complete binary tree. So complete binary tree means except the last level, all the nodes need to be completely filled. Okay, from left to right, exception only at the bottom level. So this is called as complete binary tree, and this example is not a complete binary tree. So because in this example, okay, here always okay, the property of this complete binary tree is we have to fill the nodes from left to right. So here, okay, this first level is completed, left and right is available. In the second level, B has left and right child, but C has there is no left child. Before the left child, here F is filled, right child is filled. So that's why this is not a complete binary, because if it is the last level of the tree means even though we have to fill from left long that is left to right. So in this case it's wrong. So this is not a complete binary tree. In this case also, here the C first we have to fill the left child of the C, then we have to fill the right child. So that's why wait a minute. Hmm. Okay, that's why this is called a C, not a complete binary tree. Only this example alone is a complete binary tree. I think you all know about complete binary tree. And one more tree is available, full binary tree. Full binary tree means we have to fill the nodes either with the zero children or two children, and we can fill not from left to right. You can fill anywhere, but all the nodes contains the either zero children or two children. So that is called as full binary tree or extended binary tree. Okay, so these are the two types of binary search tree, binary tree. One is complete binary tree, other one is full binary tree. Complete binary tree means here the levels are all the nodes are completely filled from left to right, only exception at the bottom level. So that is called as binary, complete binary tree. Full binary tree means so we have to fill the nodes with the either zero children or two children. Okay, so that is the full binary tree or extended binary tree. Okay, next we will discuss. Yeah, extended binary or full binary. Here each node will have either a two children or zero children. Node with the two children is called as internal nodes. Node with the zero children are called as external nodes. So this is called as extended binary tree or full binary tree. So these are the two types of binary tree, complete and full binary tree. So next we can represent the nodes in this way. So here the A means in this left representation of node structure A and has a left of a B as well as right of C. Like this for every node you have to fill. This is the representation of the tree. So next we will move on to the tree traversal concept. Wait, yeah. Okay, so next we are going to discuss about the binary tree traversal. What is mean by tree traversal? I think you all know what is mean by travel. So you are visiting the place from one place to other place, that is called as a traveling or travel. So likewise in the tree also we are going to visit the nodes one from one node to other node, that is called as a traversal. Okay, here the tree traversal means we have to visit all the nodes in the tree exactly once. So that is called as a tree traversal. So we have to visit all the nodes exactly one. So here traversal means visit all the node only once. Okay, here we have the three types of tree traversal. One is in order traversal, pre-order traversal, post-order traversal. We will discuss one by one. So tree traversal means visiting the tree nodes exactly one time, all the nodes. For example, the tree contains 10 nodes means we have to visit all the 10 nodes exactly one time. That is called as tree traversal. Okay. So next is the first type is in order traversal. We have a formula for this in order traversal. How to visit the tree with the in order traversal. First, we have to visit the left of node or left node, and then next we have to visit the node part, that is the root part. So next we have to visit the root part, that is right node. So we that is the order is left node and right. This is the order of in order. L N R. For example, I will type here. The order is cap L, N, and R. So this is the order of visiting the in order traversal. So in order means first we have to visit the left node. Next node means the root part, and then next we have to visit the right node. So this is the order of in order traversal. In this order, we have to visit the tree. So for example, here a small tree with the three nodes. So here this is the node part and this is the left node and this is the right node. As per the order, first we have to visit the left node. So here the left node is B. Node part is A and right part is C. So the visiting order of this in order traversal is B, A, C. So this is called as in-order traversal. Let us take a big example. Then you can understand better about the in-order traversal. Okay. Next we will move on to the next slide. Okay. So here the traversal left node B and no left child for the B. And next we have to visit the root node and no child of the B, right child for the B. And then visit the node A and there is a node bar and traverse the right node C. Here there is no left and right. So we are visiting the C. So this is the logic. Okay. And here this is the algorithm for in-order traversal. We have to first check whether the tree is null or not. If the tree is not null, it contains some elements means first you have to visit the tree in order of tree left first. Then write the tree data. Always we have to print the tree data node part. And then next we have to visit the in-order traversal of tree right and finally end. So this is the algorithm for in-order traversal. Okay. So next, this is the sample example. For this example, now we are going to write the in-order traversal. So here consider this as a tree, and this whole tree A is the main root, and then this whole part from B to L, this whole part is called as a left subtree. Likewise from C to K, this whole part is called as a right subtree. Again this left hand side, again we have to consider this as a tree. So in this tree again we have to check the which one is the left part, which one is the node part, and which one is the right part. So every individual node, before printing that value, before visiting that value, printing means writing answer. So before writing that node as a visited node, we have to check whether the node is contains the left part, node part, and right part. So in this order only we have to visit the node. This is the in order traversal. First we will check the first value A. Okay, before this A, we have to take a in order of left to first, no, as per the order L, N, R. So take a whole left. So in this whole left, again we are taking the, so here which one is B is a root, and with this D whole part is again is a left. So that whole part you have to take. This is the whole next subtree. And this D, which one is the whole left? G. So this G is a left. So in this left again you have to check whether it contains a left node right structure. Here there is no left and only node is available, so visit the node G. And then next there is no right is available, so only G, the node part is available, just write the answer as G. So now in the subtree, the left part is over. Next we have to visit the root node. So here the D left is over and next root node is D and print the next value is D. And next we have to take a right hand side. In this right hand side again apply the same concept of which one is left and node and right. Again you have to consider this as a tree structure. In this tree structure you have to check which one is a left, which one is a node, and which one is a right. So here again in this H means here there is no left, only is node is available H, then there is no right, right is available L. So now first answer is G, then we have to take a D, then we have to take this whole tree. In this whole tree there is no left, so print the right part, there is H, node part H, then right part is L. So this whole subtree is over, this D to L is over. So this is called as the left of the B. This whole structure is the left of the B. This left alone is over. As per the order, next we have to take the left, and then next after the left node part. So now node part is B. This B will be printed. Then the whole left is over for the B, and then node part of B is over. Then we have to visit the E, and this is the answer. So this entire left of the root node is completed. We have visited. Then this whole L is over. Next we have to print the N, that is A. So next we have to take the whole right. In this whole right, again we have to apply the left node right case. So first we have to take a C. So here C, there is no left, and we have to print the C is the answer. So next we have to take a right of the C. So in this right of C, again it is a tree structure. So this I is the left part. So print the I, and here the node part is F, and next the right part is J. Okay, here the left of the F is over. Here in left hand side only one node. Here there is no left node right concept, only node part is available. Just print the value I. So next the left is over. Next the node part is F. So next we have to take a right part. Okay, so next right part means again it contains the structure of L, N, R. Here L is K, N is J. There is no R. So next value is K and finally J. So this is the way we have to traverse a tree using in-order traversal. This is called as in-order traversal. So in this in-order traversal, so this is the answer. I think it is clear. So here in this tree, we have to visit the tree in the order of left node right. Every subtree, every node, before printing the value, check whether we have a left node and right concept. So this is the order of in order. So next we will move on to the next. Okay. So this is in order traversal. And next is a pre-order traversal. Here the pre-order means first we have to visit the node first, N. There is a root first, then left, then right. Okay. This is the formula for visiting pre-order traversal of tree. So first we have to visit the root node, and then next we have to visit the left subtree, then we have to visit the right subtree. In the previous case in order, we have visited the left subtree first, and then node, and then finally right subtree. Again left subtree we have applied the L and R, but here It's a NLR. So this is a simple diagram. In this simple diagram, so here, which one is a node part? A is a node part, left part is B, and then right part is C. So this is the way we have to visit the pre-order traversal. Left node, left and right. Next, we will discuss the big example. So this is the algorithm. So first, as usual, check the trees whether equal to null or not. Then we have to print the node first. So we have to write the tree data. Then we have to visit the okay, pre-order traversal of tree left. Then we have to visit the tree with the pre-order traversal of tree right. So this is about pre-order traversal. Now we will check with this example. The formula is node, left and right. In this example, this A is a node. Okay, the result is A. So next we have to take a whole left. So this is a whole left of A. Again, this whole left apply the logic of node left and right. So here the first node is B. Next answer is B. And then in this B, node part is over. Which one is the left part? This whole D to L is the left part. Again, in this left part, we have to apply the logic of node left right. Here, node is D. And then next, we have to check the left part. Here, left part is G. So here in G, there is no left right. So only the node part is available. Print the G. So the G, this subtree of D, the node part D is printed, left part G is printed, the remaining is right part. So this right is a H and L. In this H and L, node part is H. So next to print the H. And there is no left as per the order. So only right is available, that is L. Okay. So now this whole part of this, that is the node part is over, the left part is over, next right part is E is available. So in this pre-order traversal, the known route is printed. The whole left subtree is visited as per the order of node left and right. So the node part over, left part is over. Next we have to take a whole right part. In this whole right part, again apply the node left right. Here node is C. So first C is printed, and then next there is no left part of the C. Again we have to take a right part of the C. So take a right part. Again, we have to apply the formula node left right. Here node is F. So F is printed. So next left is I. And there is next the node is over, left is over. Next the formula, as per the formula, right. So here right again it's considered as a subtree. In the subtree again apply the formula node left right. So node is J. And then left is K. So this is the answer of pre-order traversal. So we have to visit the tree in the order of node first, left and right. In this order we have to visit the tree. Each okay no, for every subtree also we have to apply the same formula node left and right. So this is the answer of pre-order traversal. So next we will discuss the post-order traversal. This is the third type. Okay, in this post-order traversal means we here the visiting order is left node, right node, and then root part. So here the formula is left, right, and node. Okay, so this is the order of post-order traversal. In this post-order traversal, first we have to visit the left subtree, right subtree, and the node part. And let us take this simple example of the tree. In this tree, which one is the left part? B. Which one is the right part? C. And which one is the node or root? Here is a A. So the order of the post-order traversal is B, C, and A. Here, first visit the L, and second visit the R, and finally node. So this is the order of post order traversal. In the previous case, in order means left node right. Pre order means node left right. Post order means left right node. So now we will take a big example. So in this before this example, first we will discuss the algorithm. Okay, so in this algorithm, as usual, you have to check whether the tree is not null. Post order traversal of visit the post order traversal of tree left, and visit the tree with the post order traversal of tree right. First, visit the post order traversal of tree left, next post order traversal of tree right, and finally visit the tree data or print the tree data and end. This is the algorithm for post order traversal. So now we will take this example. In this example also, first we will start with the formula. According to the formula, first we have to visit the whole left subtree and whole right subtree. Finally, node part. So in this example, let us take the whole left subtree. This B to L, this whole oval shape is called as a left subtree. In this left subtree, again apply the logic of left node, left, right, and node. So left is here. The first we have to take a B and left is D. In this D also again a subtree. Again we have to take a left of this D is G. So first value is G. Okay. So this is again left subtree and here the left is G. And then the left is over. The right of this D is H and L. This will be taken next. Again this is considered as a subtree. Again apply the formula left, right node. Here there is no left. Right is available. L is printed, then left is over, right is over, and node is H. The D left part is over, right part is over, remaining is node, that is D is printed finally. So this B subtree, the whole left is over, next right is available for the B, so this right is E. E is printed next. And then the the subtree of B, the left part is over, right part is over, the node is available B. So now this whole left subtree is over. Then we have to take a whole right subtree. In this again, this right subtree again we have to apply the logic of left node right. So left, right, and node. Here there is no left, and then here again the right part is available. That subtree we have to take. Again in this right subtree also we have to apply the logic of left, right. Here the left is I is taken, visited. Then next to the right of this F is a J and K. In this J and K again it is called as a subtree. In this subtree we have to take the left part is K is printed and then there is no right part, and node part is finally printed J. So this F whole left is over, right is over, then finally node. So F is printed. And then here there is no left of the C already is over and then right is over, then remaining node, node is available C. The whole L is over, R is over, finally node, that is A. So this is the this is for post order traversal mechanism. Okay, so this is about three types of tree traversal. The tree traversal means we have to visit all the nodes of the tree exactly one time. That is tree traversal. We have three type of tree traversal. One is in order traversal, pre order traversal, post order traversal. In order means we have to visit the tree in the order of left, node, and right. Okay, first visit the left subtree, then visit the node, and node is nothing but root node. And next we have to visit the right subtree, that is in order traversal. Pre-order traversal means the formula is node. Visit the root node first, then row left subtree, right subtree. That is the pre-order traversal. Post-order traversal means visit the left subtree first, right subtree first, finally node. So in this whole tree, again we have to consider the subtree. Every subtree also we have to apply the formulas. For example, post-order traversal means first you have to take a subtree. In that subtree also again apply the logic of which one is the left and which one is the right and which one is a node, L or N. The same you have to follow for every recursively. So this is called as tree traversal. Thank you. We will discuss the binary search tree in the next session. Thank you all.